So far, and we look forward to talking about the demand for tech skills and its impact on higher education. Very fortunate to be joined today by Jeff Forbes, Susan Buck, Tom Ogletree, and Pat Youngpretty, and I'm going to let each of them briefly introduce themselves.
So, good afternoon, everyone. My name is Jeff Forbes. I'm here in my role helping out the National Science Foundation with a great title that they call expert. Sometimes it's called intermittent expert, which I like even better because it says something about my expertise. And what I do there is I work on their programs that are focused on computing education and broadening participation in computing more broadly. So that's, and if you don't know what the National Science Foundation does, it's a federal agency that funds research and education in science and engineering in the United States. My day job is I work at Duke University in North Carolina. I'm a professor there and a academic dean, and my faculty home is in computer science, so I think we'll have lots of computer science discussion here today.
Excellent. Hi, everyone. My name is Susan Buck. Also have spend my time in computer science in three capacities. So the first capacity is I work at Wellesley College as a lab instructor, and I work there with their intro courses, so they're working with Python. And I also teach a course every semester with Harvard Extension School, a few hundred students, continuing education students, teaching them how to build dynamic web applications. And then finally, the third thing is I co-founded a group called the Women's Coding Collective. If you've heard of MOOCs, massive online courses, ours is what they call SPOC, small private online courses. So we try to reach out and get more women involved in tech and minorities and other underrepresented groups, and try to recreate some of the environments that we see in person, try to create them online as much as possible, hence the small private part of it. So yeah, those are my three day jobs, and I'm interested in how all three of those are very different in terms of the audience and how that impacts the conversations we're going to be having today.
My name is Tom Ogletree. It's a pleasure to be with all of you here this afternoon. I'm Director of Social Impact at General Assembly. We are a global education company founded about 6 years ago in New York City that teaches courses in web development, user experience design, data analytics, and other relevant employer highly in-demand topics by employers. And the way that I really fit into General Assembly, which has really been focused on reskilling career changers who have liberal arts education backgrounds that are sort of looking to get into the tech sector. We've had a lot of success reaching that audience, but I'm really tasked with a GA. How do we make sure that these types of accelerated training programs and technology skills are really able to reach folks who may not have finished a four-year degree, who've gone to community college, who have faced barriers to education and employment, and while I'm thinking through all the different ways that these types of models can really promote diversity and access and socioeconomic mobility.
And hi, I'm Pat Youngpretty. I'm the Chief Academic Officer at Code.org. Raise your hand if you've heard of Code.org. Okay, well, I'll explain what Code.org is. Code.org is a national nonprofit. We promote computer science education around the nation. We are the organization responsible for an event called the Hour of Code, and maybe you've heard of that. If you haven't heard of us, which is actually a good thing that you haven't heard of us, but you've heard of that, because it's a community effort. But Code.org does a number of things. We do four things. We create curriculum, and we train teachers. We've trained 43 or 45,000 teachers over the last 3 years, and that's all in-person professional development. We create tools for students, tutorials, coding environments, environments that allow you to create an app in like 5 minutes and have it on your phone. We do a lot of advocacy and policy work at the federal, state level. We were one of the groups that were responsible for getting computer science in the STEM Education Act earlier in 2015, as well as the Every Student Succeeds Act, making computer science part of a well-rounded education. And we do a number of other things as well. We celebrate computer science through things like the Hour of Code. We create videos, etc. I lead a lot of the policy work, and actually today we launched, along with 4 other organizations, the Association for Computing Machinery, the National Math and Science Initiative, the Cyber Innovation Center, and the Computer Science Teachers Association. We launched k12cs.org. You can go to it if you get bored during this talk, which you won't. And we launched a framework for computer science education, similar to the National Research Council's framework for science education 3-4 years ago. Thank you.
And I'm Nick Dukoff, Vice President for New Ventures at Northeastern University. We've got a great group comprised of nonprofit folks as well as General Assembly, which is terrific, and excited to learn more about really what is the demand in the market for tech skills. We learned this morning in Jeff Zelenko's keynote that of 20 million job descriptions, 80% shared 5 common characteristics. 4 of 5 were soft skills, and the 5th, the technical skill, being Microsoft Excel. What other tech skills do you see demanded in the market aside from Microsoft Excel?
So I can speak to that to start off. So for me, a big part of it is, I think broadly, just digital communication. And underneath that umbrella is very much web development. What used to be, 7 or 10 years ago, everybody needed to know like word processing in order to convey your thoughts and what you were working on. Like today, the equivalent is basic web publishing. So if I had to pick one skill that's, under this umbrella of computer science, it's really that, because the internet just makes it so easy to put out your ideas and your research and your opinions and all of these things that it touches every field. So, and that is something I see time and time again with students across the range, whether it be the undergrad students who are looking for internships or the continuing education students that are coming back trying to get these skills they don't have, is like those skills are, they're always the footnote on the job descriptions. So whether it be looking to get a job or even, further what you're trying to do if you're continuing in academics and research and that sort of thing, it's a voice is what I see it as. So those technical skills, I really feel like if you are not having them, it's really a disservice.
So one of the things when I think about what the citizenry means, it depends on like who you're talking about, right? So at NSF we care about things like, well, we want a robust computing research workforce. Well, that's nice because if you want more Googles and things like that, that's good. But that's not really a broader audience, right? If you think about the workforce, you really want the computationally empowered workforce, right? You want to be able to have the skills such that if I'm doing work in science, right? If I'm doing work in social science, even if I'm doing work, if I'm just trying to publish, right? I need to be able to use the tools that are available and help develop and really adapt those tools to do more, right? Because there's so much out there right now. It's very different than, back in the olden days when I was in college, where like if you wanted something, you have to write your own program to do it yourself. But no, even though there's so many tools out there, in order to adapt them, in order to understand what's possible, I think, through efforts like, what Pat's done, well, I'm not giving it all to you, but code.org, because there's more than just you who works for code.org, I'm pretty sure. Okay. But just in terms of making it so that every student in the United States, we want to, every student in the United States should have the opportunity to at least write a program and learn what that's about and learn what the fundamentals are of everything that they're using, right? That no matter how they're interacting with the world, it turns out that there's so much computing involved. And you want to have that exposure in order so that you can be empowered to do more, right?
And if I can add on to that, so it's not about, and actually to you too, Jeff. Thank you. Jeff is one of the advisors to the K12CS framework. He didn't thank himself. But piggybacking on what Jeff was saying, it's not about kids becoming programmers. So, none of us are saying that every single kid needs to become a programmer, a coder, a software engineer, a particular technology specialist. What we're saying is that kids should be empowered as computational thinkers. So that's the buzzword that you guys should really clue in on. It's called computational thinking, which is the idea of figuring out how to design a solution so that a computer can help you solve it. So harnessing the power of computers to help you solve a problem. And that doesn't mean Microsoft Excel most of the time. So just inputting data into a spreadsheet is not computational thinking. But creating formulas or writing equations, scripts that allow you to automate the process so that you can tackle larger problems and larger data sets. That's computational thinking. Decomposition, breaking down a problem, abstraction, layers of abstraction, and just creating the algorithms like in programming. These things empower all kids to figure out how to use computer science, technology in any field.
And I would agree with everything that's been said. And I think what's interesting for how, the angle that I come to this is, really through, folks who are job seeking, who are trying to upskill and sort of start new careers using these types of disciplines is that, I think about my grandfather who worked at one company for his entire life, got all of his training on the job. And I think the way that, we can, a company like General Assembly can complement the great work that's being done by my fellow panelists in terms of unlocking that type of computational thinking, providing context and frameworks for young people at every stage of their academic career to sort of think like developers, even if they're not full-time developers, is once they get out into the workforce, the way that we've really seen our role play out is that, the most in-demand skills are changing in real time, right? And what we can really do is train people in a lot of these sort of frameworks, but they're much better served by programs like General Assemblies if they come to us with those frameworks and we really focus on, okay, what's in demand for the marketplace, what's in demand for the job, how can we get you upskilled so that you're ready for whatever is next, either that next promotion or that next stage in your career. And I think especially is what we're seeing that, increasingly jobs are hybrid jobs, right? It used to be marketing was over here and then the web developers were over here. Now you need both of those things, right? And so I think where we really enter into all of this is sort of building on the types of frameworks that people establish, in the K-12 space, in their academic careers, in their early careers, and then creating a platform for folks to continue to build up their skills, continue to learn, continue to grow as demand in the marketplace shifts in real time.
So I think both of what you just said ties into something really interesting. So Pat said, not everybody needs to be a programmer. And I think that's important to get out there because I think with all of this wave of like, learn to code, that there's this misconception that people have to be a programmer. And it's not, yes, many people will and go in that track, but it's what you said, it's this idea of programmatic thinking and that skill set of problem solving and troubleshooting that is applicable. And I think the other thing is it's getting exposure to that because even if you're not programming, you're going to be working with people that are programming and you want to have the technical vocabulary to be able to communicate with them. So the selling point has to be about like, this is a way of thinking and this is going to overlap in what your specialty is, even if you are not necessarily a programmer.
So to stay on this thread, what are the soft skills that accompany computational thinking? One that I can start with, and then I'd be curious to hear what the rest of you think to add, is self-service. So one of the notions of being connected to the internet 24/7 is that in today's workforce, people are expected to be able to answer many of the questions themselves, be able to troubleshoot software, be able to develop apps that can increase their productivity, and being able to use what you were just saying to have the vocabulary to know what questions to ask to be able to find those answers. What other skills, be it technical skills or soft skills, do you think accompany this notion of computational thinking?
Let me jump in. Because I have a specialty here, my specialty is the K-12 arena. So even before we get to higher ed and after higher ed and what education students can pursue, what we're building as a base at the K-12 level are 7 practices for computer science. So if you're familiar with the standards movement over the last 5 to 10 years, you understand that the Common Core and the next generation science standards have these practices. And so practices of math include dealing with precision. Practices with science deal with things like modeling or arguing with data. And so with computer science, what we have are some soft skills. So I'm not going to talk about the technical skills. The soft skills are things just like collaboration, but a specific type of collaboration, a collaboration that takes in all different perspectives at the beginning of a design stage to understand a diverse set of end users. So that's a soft skill that all students need to understand. So it's not just your general run-of-the-mill collaboration. It's collaboration with an intent to serve a population, a diverse population. So that's one thing. The second thing is obviously just communicating your results, but communicating the process as well, and communicating the development process. So the decisions that you made, the rationale, and then sharing that with a large group of people beyond just the people you're working with in person, but using the internet, using forums, things like that. So these are some soft skills that we believe every student should learn, and hopefully through the K-12 CS framework, they're going to get a taste of that. And so from there to higher ed, and then to the job place.
So in terms of, I think they're adding a couple of things. One, scale, right? So I mean, it's a technical concept, but it's also a concept that I think is really applicable to what you're going to be doing at your company, right? No matter where you are, you might think about, what can I do to test what I'm trying to do in the small? Like, what am I doing when I think of a couple people thinking about this? And then what's going to happen when this goes out into the wild? And then you have hundreds, thousands, and one of the crazy things now is it's not that hard to create something that all of a sudden has millions of people engaging with it. And then you're having effects that you've never really considered before. And another thing is, when you think about communication, you also have to think about the cost of communication. That there's this concept of the mythical man month, right? Where if you just add in more and more people, you'll get the job done faster. But it turns out that's not true. Right? In many cases, there's a significant overhead for synchronization, for communication. So you want to think about, I want this project done, and that's, you'd like to get this done, but you can't just throw more people at it and say, oh, it'll be fine. If we throw enough people at it, we'll get it done by the deadline. If you throw more people after it, then actually you'll get it done even later than you did before. So those are at least two of the big skills I think people need to think about that are related to computing, but I'm sure you guys have more.
I mean, I come at this from a slightly different angle because a lot of my work is focused on adults with barriers to education and employment. So many of the folks who we're serving through our programs and through partnerships with really amazing nonprofit organizations like Perscolis in Europe is really where a lot of the audience are folks who have only worked in retail or manufacturing or food services and haven't been in sort of in startup environments or working at big companies. I mean, I think that there are not only a set of sort of CS oriented soft skills that I think both Jeff and Pat really spoke to eloquently, but there's also sort of a broader set of objectives that we need to think about as we're preparing people for 21st century jobs around, emotional intelligence, around good communication, around, what is sometimes referred to as quote unquote professionalism. These traits that you don't necessarily learn by osmosis if you haven't been sort of coached through those different settings, and that, in many cases I got either from the jobs that I had as a teenager or the internships I had in college or just sort of learning as I sort of started my career in my early 20s. But I think that there's sort of also a broader set of questions that we need to think about collectively that are not just oriented to CS skills specifically, but really takes into account the fact that as the workforce is shifting in such dramatic ways, we need to fundamentally rethink, as we're thinking about the pedagogical models and frameworks that can teach these kinds of computational skills, how are we best in preparing people, especially young people who don't have a lot of access to opportunity, to be ready for today's workforce.
So it's really clear that the demand for these skills is growing. Both on the supply side, there's a lot of interest bottoms up in acquiring and developing these technical and soft skills, and also the demand from the demand side, from the professional side of the labor market is of course wide and growing. Many employers say that they can't find the talent that they need to fill the gaps at their companies in these areas. How do we as educators service the supply, the growing demand on the supply side, the student side, the learner side, when it's so hard to find people that know how to teach these topics?
That is a very, very good question. One thing that's also happening, so you mentioned this mismatch, right? That there are all these people who are now interested, but then employers keep telling us we can't find the people they want. And part of what we're seeing, and I'll both in my role as a professor and my role at NSF, is employers have, I'm going to try to be nice about it, but sometimes unrealistic expectations, right? That they want people to come in with basically what would have previously thought of as being like something you would learn by having both a PhD in statistics and computer science and be like the most like best business person that you've ever seen. And there exist some of these people, right? And the problem is some of these people do come out and they have this incredible skill for thinking about data, thinking about how to visualize that data, and thinking about how to communicate that with everyone. But that's really hard to do. And what our challenge is as people in universities is to think about how we can scale some of those really important lessons down, right? Instead of saying, well, once you get to this stage, like after 5 years, then you'll be actually useful. One thing we're doing is we're bringing the problems lower, right? So, and I think that's, and that's something also we've worked on with Pat, as well as thinking about how can you get really interesting problems into early computer science courses so that you're no longer like converting from Fahrenheit to Celsius, but instead you're doing some kind of participatory design project where you're thinking about, the temperature readings in your town and how those vary based on stuff I don't know.
I find this really interesting because we've been working with a really well-known large global technology firm who's been underwriting the cost of scholarships to General Assembly programs for low-income women and people of color. And there are these extraordinary young people who are putting their lives on hold to take these programs, many of whom have very sort of unstable home and life circumstances. And what we've been talking to this company about is they say we don't really need we're language agnostic. We need them to be able to think like developers. That's what we really care about, and that's really the way the General Assembly thinks about our training in these programs. But what's been fascinating is that as they've completed their training and started apprenticeships at this company, we go back and say, how are things going? How do you like this person? They're like, well, she's great. She thinks like a developer, but she doesn't know X, right? And so it's kind of like, okay, that makes it a little tricky for us. And I think that there's a breakdown also on the demand side from employers where you can sort of say, okay, there's a C-suite mandate that talks about diversity and inclusion and building a more inclusive tech talent pipeline. But then when you get down to HR practice, and then when you get down to individual hiring manager behaviors, there's often this really fundamental breakdown. And I think against that, it can be really hard, especially for the higher ed space, to think through, okay, well, how do we prepare people to succeed in the workforce when the signals that we're getting from employers are so conflicting and ambiguous a lot of the time? And then how can we be thoughtful about packaging that in when a lot of the time employers aren't 100% clear on what they want?
So this is something that I'm interested in listening to both of your perspectives, because it sounds like you're describing this gap in expectations and reality with these companies, and then it sounds really interesting with this kind of corporate sponsorship that you have going, because so at Wellesley College, we're seeing this a lot where there's this demand in the workforce. So companies like Google and Apple are coming in and they're sending people to give talks, and essentially what they're doing is they're planting seeds in this garden of potential workers. That I think that's where it starts, and that sounds really great what's going on at General Assembly, because that is going to be developing the workforce. So it's not so much plucking out when they're done, it's like getting in there early and teaching the skills. And I think the benefits of that are twofold then, because I think another problem that is going to be a topic of conversation is we're trying to answer, well, how does higher education meet these demands? And I think that part of that is having more from the outside world come into the walls of the academic institution to bring in these ideas. Because what I see sometimes is, especially in computer science, there's a lot of faculty, they're really good at research. They are good at all these traditional academic things we think about, but they're disconnected from the industry. And they are out of touch, essentially. And a lot of students are graduating, and then they're feeling disgruntled because they're not getting these skills that these companies are then asking for. So if there was more of a partnership between the academic institutions and the companies that are hiring, and this kind of cross-pollination going on, I think it would help both sides of the picture.
Yeah, and if I may chime in, so the problem is that we know that we need to build a diverse tech pipeline, but we don't have the educators to do so, or maybe the programs to do so. In fact, a number of you all are you represent higher education institutions. there are very, very few, probably just like a handful of computer science education programs in the nation. And that is a problem, because how are you going to create the educators to teach the kids? One thing that all higher education institutions can do that's a lot smaller a lift, lower a lift than creating a computer science education program to create educators to teach kids, is to simply count computer science towards an admission requirement. So I'll say that again, to count computer science as an admission requirement, because right now, in most of your institutions, I'd venture, you don't count computer science towards the core admissions requirements for your school. So things like sculpture or pottery probably count as a fine arts credit. But things like computer science, I mean, a kid took it and it really doesn't give them anything in terms of their admission requirements for Harvard or other schools. I didn't want to put Harvard out there. Actually, Harvard might count it. I don't know. But what I'd ask you to do is, if you are part of a higher education institution, is go back to your admissions group and ask them, so how do we count computer science? They might look into it and like, I don't know, off the top of my head, it's an elective, you know? We count it as an elective, which means you don't really count it. And so there's a nationwide push to count computer science as a core credit. A lot of people are doing interesting things. They're counting computer science as a math credit, as a science credit. Some are counting as a foreign language credit. I don't suggest that. But math and science, that makes more sense. So think about that.
And can I give one thing? Like when your admissions people come back to you and say, "Well, we don't know," like they can't. The argument they give is they can't tell what the quality of a computer science course is. Right? That's what they sometimes will say, and I can understand that, because in some places, what computer science might mean is you learn how to type. Right? However, that it seems ridiculous when they also apply that to AP computer science and all kinds of other computer science courses, while at the same time accepting, pottery or whatever as, not that there's anything wrong with pottery, I'm just bad at it, as something that should count for college.
Now that we're on the topic of transcripting, I'm going to move a little bit over to curriculum. And one of the things that I think is interesting about this panel is you each serve very different populations. And so what I was hoping you would each do is just share a little bit about the demographics of your population, and then, what are kind of the top level learning objectives in your computer science or tech curriculum.
So if I speak for the National Science Foundation, our students are kind of all students, and in particular, we're responsible for maintaining the health of the research pipeline. So, and that does not mean just undergraduates at research universities. Because in fact, increasingly so, we're seeing a lot of students who are coming through lots of different pathways, right? Someone may be going from 2-year to 4-year colleges. In fact, one of the projects we worked on a lot was right here in Massachusetts, working with a number of an alliance of universities that was trying to really do a better job of thinking about that articulation between 2-year and 4-year institutions, so that students would be better prepared both for college and beyond. So that's what our population is. And it's interesting as we look at the enrollment trends. So there's been enrollment growth at a lot of institutions, but it's not uniform. There are some schools that are getting huge increases, right? Some of the big research institutions just getting ridiculous number of students. They can't handle them. And that's something that, in particular, I'm trying to come up with a program to address. But then there are also schools where they have, either flat or, different kinds of enrollments. And then there's also the big enrollment in informal ed, and also big enrollment jumps in some for-profit institutions. And it's important to consider all of these different types, because sometimes when you look at the increase in computing degrees, you think that means students who are getting degrees from places like Wellesley, and that's not accurate, right? It actually turns out that it can be a very varied set of students getting those degrees from very, very different institutions with different outcomes.
Yeah, so as you were talking and as that question, I was thinking about Wellesley, because we are seeing a surge in the demand for computer science courses to the point where we're having a hard time keeping up with it and hiring new faculty and funding that and having the courses to support it, because it's such a huge demand. And one of the things I think also is something to think about if you're designing things and you're thinking about these programs in your institution, there might be a need for two different tracks. The general education, all this stuff we're talking about with programmatic thinking, and this exposure to these sorts of topics is often a very different need than the student who actually is going to focus wholly on computer science. And I think if you try to join those two things together, it's often doing a disservice to both sides. Often the pace is too technical, it's not applicable enough for the student who's just trying to get the exposure to it. And then on the flip side, if you're focusing more on the student who's taking it as a gen ed course, they're not getting the hands-on examples, which somebody along the line here mentioned that, of seeing practical uses and examples. So as this demand increases, I think that needs to be thought about, and valuing computer science as one of the general education requirements. And I think that plays out a lot of what we're talking about with the K through 12 system. So that's one of the growing pains that I'm seeing with this demand in Wellesley as a more traditional example. And then the other role, so at the extension school, I'm working a lot with continuing education, and you're dealing with people who have been out in the industry and they've been laid off, or their skills are no longer up to date and applicable. I mean, everything we can imagine the reasons they're coming in for, and those students especially, I see them as trying to make the transition into a development field. They want to be developers. And then the third category I mentioned that I'm a part of with the Women's Coding Collective, that's more of I work for a nonprofit and I need these skills for the job that I'm doing. Or, somehow I have a business idea and I need to communicate with my developers. So those are really three different kind of needs and populations to be serving.
So General Assembly's audience is adults, 18 to late 60s, early 70s. The vast majority of folks who come to us are between the ages of 25 and 35. They're college educated. They're looking either to get upskilled for their next promotion or to change careers. So, we really work closely with employers to develop all of our curriculum. So, we look at labor market data, burning glass data, really try to understand what's most in demand in the sector, and then in partnership with practitioners, build our curriculum that really speaks to that employer demand. And so, over the past 6 years, over 300,000 people have come to General Assembly classes and workshops. We've had 25,000 take our part-time programs. Most of those are for folks who already have a job and are looking to, get some additional skills in, user experience design or data analytics to, help bolster their career growth, and 40% of those programs are paid for by employers. So people are using PD funds to take those programs. Then you have our immersive programs, which are for career changers, 12 weeks, all day, every day, very intensive, really designed to take folks who are novices and turn them into practitioners. Then we have a whole career placement team that works not only on the employer side to pitch graduates of the programs, but also works with individual students to help refine their projects to position themselves effectively for the job search. And I think that really drives our very positive outcomes in terms of job placement, which is 99% of our job-seeking graduates find work with their new skills within 6 months of course completion, most of them very much earlier. But I think that what we're really struggling with too is as we how do we stay responsive to changes in demand in the labor market? How do we make sure that the suite of products and offerings and tools that we have are reactive to what we're seeing in the marketplace? And then I think we're also seeing some interesting challenges, because what a lot of folks who are coming out of our programs, they're building on that college education, right? So they have that liberal arts foundation, they have that workforce experience, so they've had experience working in teams, and they have higher levels of emotional intelligence, and they sort of know how to lead and manage peers. And so they're often bringing that experience to bear as they're getting entry-level junior developer roles at big companies. And I think we're trying to figure out now, how do we make this model work for more people who may not have that background and that foundation, that education? And it's a lot harder. And there are a lot of sort of nuances and complexities to it that, while I think that accelerated training models like ours can be really powerful workforce development solutions, and for some people can maybe be something that can sort of serve folks who may not be a good fit for sort of a 4-year liberal arts experience, but that's really the exception rather than the rule. So I think that we're really trying to struggle with, how do we participate in this whole ecosystem with groups like Code.org who are providing that early exposure, with colleges and universities, with the workforce system, with employers, to really understand how models like ours, that are in some ways some of the oldest educational models in the world, right? You learn from a practitioner or a trade in a very short period of time. This goes back to the medieval guilds, right? So, it's not new, but how do we make that work in today's economy in a way that's really powerful, especially since, employers are saying, we don't want to be on the hook anymore for training and development and sort of getting people ready for the workforce. And colleges and universities, I think, are put in a tricky position in terms of what their roles and responsibilities are. And people are changing jobs in real time, so you're not having that longevity of, growth in a particular sector. And obviously I'm making a lot of generalizations here, but I do think that there's a lot to be said for how all these different types of training and education models can work together in a really powerful way to best serve the needs of today's workforce.
So quick audience poll. How many people are familiar with boot camps in the educational context? And keep your hand up if you're familiar with General Assembly. Great. So given the pretty affirmative interest and understanding of the market, question for you, Tom, and then Pat, we'll get to you, is do you see boot camps as competitive or collaborative within the higher education ecosystem?
100% collaborative. I mean, I think, and that's what I was speaking to just now. There are a lot of things that we can do. There are a lot of things that we can't do. And I think that what we've really struggled with is, how do we make the type of training and experiential learning that we're offering at General Assembly, relevant within a 4-year degree ecosystem. We've had more success with community colleges, mostly though through schools of continuing professional education, where there's a sort of a high demand for workers to kind of quickly get additional tech skills. I think the thing that we really struggle with is getting the funding models to make sense, and this is where we've had a lot of conversations with the White House through the Tech Hire Initiative, through the Workforce Investment and Opportunity Act, sort of understanding all the different levers that may be available to sort of make these types of programs accessible for folks. Because while we're cheaper than graduate school, we're still pretty expensive, and that means a lot of people are sort of left out of the equation. And so I think that it's all of us have a role to play, and I think that there's going to be I think it's going to be interesting to sort of see how the policy landscape around some of these issues evolves, especially post-election, to sort of understand where the real areas of opportunity and what are the incentives where you can maintain quality assessments and quality outcomes and get people the skills and the training they need, while also sort of recognizing the fact that all these different actors need to be in place in order to set people up for success.
I apologize, Tom, in advance, because I'm going to ask you a question and try to spice this up a bit. So, Tom, if I were to go back in time, actually no, that wouldn't make any sense. You guys wouldn't exist. If I were 18 years old right now, and I knew that I wanted to be a software developer, I wanted to work at Google, Microsoft, whatever. Honestly, Tom, with all this boot camp stuff and General Assembly and all the marketing that I see, I would think, you know what? I'm not going to spend 20, 25K a year, 30, 35K a year for a 4-year program. I'm going to go to these boot camps. I'm going to sign up for General Assembly. They're going to get me exposed to the exact people that I want to work for. They're also going to give me a pretty good education as well, so it's not just a networking opportunity. And I'm going to achieve my dreams through them. I'm not going to do a 4-year program. My question to you is, what would you say to that kid?
I would say probably not a good idea. Like, I got to be honest, and I really do think that, well, first of all, if you're going to General Assembly, you're not getting jobs at Google and Facebook, right? Because they're hiring from MIT and Stanford at a very narrow group of really top tier, CS programs, right? So let's put that to the side, right? They're going to be
having opportunities for really good, high growth, entry level jobs in web development, either at a startup or, we do very well with financial services firms and other companies that are hiring developers like crazy, but have a lot of trouble competing with the Stanfords of the world for talent, right? So, the stat I heard the other day is that Goldman Sachs has more developers than Facebook does, right? So you're seeing this dramatic shift in terms of who technology companies actually are. So that's piece number one. We do have some students who come to us who are 18 years old, who we go through our programs. We have a hard time placing them in jobs, more so than other students, because they're not bringing that workforce experience, that college experience, that life experience to the table that you really need to be able to be successful in a job hunt. And I also think that while in select cases that can work for folks, I think we do better for people who either have gone to college and been in the workplace and are career changers, or who have, for lower income folks who maybe can't afford to go to college, but have worked their way up in retail or in food services, have some leadership abilities, have worked in teams, have the grit, the perseverance, the potential to succeed in a program like GA's. We're a really good solution for folks who are career changers in that market. I do think, though, that for folks who are 18 years old, choose the idea of coding boot camps as an alternative to college. I think doesn't make much sense.
Can I pile on?
Yeah, go for it.
Oh. So how about relative to getting a master's?
But I think that's an interesting question because, I have a master's degree. It was 2 years of my life, 2 years of my working life that I gave up. I'm going to be paying off those loans, and for a very, very, very long time, my husband and I pay more every month in student loans than we do in rent. So I do think that there are use cases where an accelerated training program like GA's probably has a higher return on investment, especially in the short term. But again, I don't think that that's necessarily, do I regret, would I change my choice about where getting my master's in public policy? No, of course not. I think it was an amazing opportunity for me. It was the right fit for me. But I think for a lot of our folks who are saying, I'd rather spend 3 months and a lot less money and then be skilled up for this than have to sort of think about entering a 2-year program where I'm going to have to sort of start from the very beginning and take 2 years out of my working life and all the earning potential and not necessarily have a clear sense of what my job outcomes or prospects might be, depending on the program.
So I'll just say personal experience too, same boat. If it wasn't for the fact that going to beyond grads or undergrad gave me the ability to teach and have those credentials, if it wasn't for that, I would probably vote for General Assembly in terms of programming. It would have been I would have got a lot more bang for my buck.
I would also say, Jeff, that we're not a one-stop shop for folks, right? Because often what people do is they'll take a part-time course with us, they find that they're really good at something, they want to do more, they'll take a related discipline, another part-time course, they're like, I'm really good at this, I'm taking your data analytics part-time course, data science part-time course, I want to take your data science immersive. And then they come to us, but then they come back and they come for workshops and classes and other opportunities or, professional development opportunities. So I think that,
So Tom, when you add all that up, how close to a master's does that get?
I think that it depends on what are the goals of the students and what is the desired outcome, right? And I think that you can look at that in terms of a time commitment. You can look at that in terms of a cost. And there are a number of different ways that you could slice it. I probably can't do that math in my head right now, but I do think that our value is really as a participant in a broader ecosystem of education and training providers that I think has really sort of shifted the sort of model where it was you either go into what was called career technical education, or you get, a 2 or 3 year master's degree in a higher end subject, and those were sort of your options, right? Or maybe you go through to a school continuing ed program at a local university, right? So I think what we're able to do is to say, okay, we have this great community globally. We have practitioner-driven training. We have employer-driven training. We're we're engaging folks on these 21st century skills. We're part of this broader ecosystem of training providers. And if that's something that's going to be really drive value to you in your career, we're a really good fit for you. Are we this sort of magical solution that's going to replace college or the higher ed system? Not at all.
Sorry, Nick. Can I say one more
please.
thing?
Yeah, we'll open it up to questions.
Yeah. And so I asked that question, Tom, because based off of my view of boot camps and all that, I always felt like if I were a higher ed institution, I'd feel kind of threatened by boot camps. But based off of what you said, you've kind of clarified my misconception that we can't just be an. Actually, you're very right. I mean, I used to teach 18-year-olds in high school, and if they jumped into General Assembly, it'd be a waste of money, and then they'd be really lost, and then they'd probably just end up going to community college or a four-year university the next year or something like that. So,
and I will say too that we really try to make sure that our value proposition to students is that we can get them jobs. So if we don't think we can get them a job, we're not going to admit them into our program.
Yeah.
And so I think we've been really trying to be very, very disciplined about that. And I think for a lot of folks who just don't have any workforce experience at all, you're just not ready.
Yeah, and other boot camps probably don't take the high road that you guys do, in terms of, probably suggesting that people take a different route. And so for higher ed institutions, I'd probably, so rather than a threat, I'd probably imagine this as an opportunity. So really understanding their model, like what is the pull? And thinking, so if they are gonna pull from maybe a small portion of the pool that you guys are pulling from, how do you have to change your program model, your business model to learn from these boot camps? Because I'm sure kids want to go to college, they want to have that experience, but they also want it to be practical, and they don't want to pay oodles and noodles of loans afterwards, and they want to actually get a job. And so I guess the idea is like, what do higher ed institutions need to do to learn from boot camps?
Yeah, and shameless plug,
Yeah.
my institution, Northeastern University, we've developed our own boot camp
Yeah.
called Level, and we started in data analytics and are now growing to a number of disciplines: cloud computing, entrepreneurship, Internet of Things, and we're looking at others. So we are seeing more and more universities join us in developing their own programs, as well as partnering with private sector boot camps like General Assembly that do a great job. So I want to make sure we have some time for questions.
Last point around higher ed feeling threatened by boot camps, maybe. I feel like if the boot camps agree and higher ed agrees that four-year degrees are really important, I feel like it's important for I feel like legislators need to be at a federal level that it's still important, because that's what's really hurting young people and their parents, is that they're getting this information that given that's resources. Money for it, but and so once the higher ed may not be thought of as front runner for really be worth.
I think they can be. One of the things that one of the panelists earlier today talked about was a multi-year governance cycle, and I think that we need to find ways at the higher education institutional level to compress those governance cycles, because these industries are changing incredibly quickly. One of the things that General Assembly does really well, and I imagine Wellesley, Duke, and others around the tables here today do it well too, is making sure you're adapting to the changes in the market. And that doesn't mean developing students for the workforce. It means creating education programs that are robust, but also are relevant. And maybe that's a question for the panel. How do we ensure that our computer science, coding, and tech skills programs are relevant in an incredibly quickly changing landscape?
From the K-12 perspective, we espouse 5 different concepts. So computer science, to most people, is usually equal to just coding. And there's a lot more to computer science than just programming, creating a program. So we have 5 different concepts in our K-12 CS framework. And Massachusetts is actually one of the states that participate in the framework. There are a number of other states as well. And Massachusetts actually has some new digital literacy and computer science standards that they just came out with. So the 5 concepts that we have are computing systems, and the emphasis is actually on systems and systems thinking. And then the second one is networks and the internet. Third, just data. So all your big data, data analytics, all that stuff comes into play there. Fourth is programming and algorithms. So not just the program itself, but just algorithmic thinking in general. And then lastly, number 5, impacts of computing. So the social, ethical side, the legal side, the policy side. of computer science. So by providing a foundation like that, you get kids able, the general education population, you get every student able to either use it in their field of interest, whether it's dancing or creating a dress, fashion design, or whatever. I mentioned those because actually I know people who are using computer science in those fields, or becoming a programmer, software developer, or what have you. So building a diverse population, a diverse curriculum set from the beginning.
Related, semi. One is that higher ed institutions are my observation that as ourselves have a desperate need for people. I always hire for this myself. We can no longer afford to hire people who won't have itself. That's just one general observation. But the other thing is kind of speaking to your point and generally thinking about how we integrate other parts of the curriculum, not just the computer science, humanities and some of these other places. Coding boot camps, those technical things are so fundamental to having places for them. Humanities students take.
I'd argue that, you know, an introductory data analytics course, though, would be quite relevant to that student.
Yes. Most of our institutions are not going to.
I mean, I think about if I look at our student projects, and you can see them all. It's called General Assembly Gallery. They're really amazing, and people are using, you know, websites and data to tell really powerful stories about, you know, refugee migration patterns throughout the United States. And so it's not necessarily oriented specifically just to the technical skills, but in the same way that, you know, a lot of us, you know, as you said earlier, you know, had to learn how to write clearly and, you know, express ourselves verbally in a compelling way in the classroom. This becomes another sort of communication tool and resource that people can use in whatever discipline that they're pursuing.
And I guess I think of it almost across disciplines, right?
Right.
Yeah.
I kind of look at this also as another way in which we
Any other questions? How are we on time? Wrap it up. All right. Well, any last comments from the panelists?
Just my last comments. I'll wrap up with an answer to your question, ma'am. So there are actually a number of programs that have been funded by the NSF. I think Jeff probably funded them at different universities. So you might want to look at media computation at Georgia Tech, which literally is the class that both you guys are thinking about. It combines the humanities and arts and computer science for a general education population. So these are not CS majors per se. And actually, every single student at Georgia Tech needs to take this course, Jeff?
You need to
Or is it
take
a
a
CS
course.
Yeah, that's right. And most of them allow them to take this course because it's not the intro to computer science, which, by the way, is often not applicable outside of computer science because it's just coding. It's not data analytics and other things. So and then my closing words are just read the K-12 CS framework.
I will end where I started, which is pushing for web publishing skills, because I think when you talk about digital humanities or any of these things, you can find a use for it, and it's going to be greatly an advantage for the students.
Yeah, I think from my perspective, it's really about how do the different intersections in terms of how we develop folks in the K-12 space in higher ed as they're entering the workforce and working with employers and then continuing to grow and learn over the course of their careers, that we're having to all of us are having to fundamentally rethink this right now. And so I think that there's a lot of opportunity through conversations like this one to really sort of start to sort of dig in further about what does it mean to introduce these concepts and frameworks at a very early age? How do we carry that through in a powerful way when people are in higher ed? What are the hybrid models of training and development that are going to be really powerful for folks? Then how do we work with employers to think about making sure that people still keep their skills relevant over the courses of their careers when demand is just changing in real time?
And the only thing I'd add to your point would be that one of the trends we're seeing is that students from outside of computer science are taking not just one course, but like 3 courses. And I think that gets a lot more towards useful. I mean, I think an intro computer science course by itself could be quite useful to a humanities student, but I think more broadly thinking about the kinds of sequences and pathways for people who are outside of computer science and, a couple 2 to 3 courses, because it's unreasonable to expect that someone who's had no computer science is going to get everything that they need in one course. I mean, that's really hard to do. We don't expect that for math. We don't expect that for writing. So I would hope we could do a little better with computing.
Well, Pat, Tom, Susan, and Jeff, thank you, and thank you everyone for engaging in discussion today.
Good wrap.